Here we go, in 3, 2, is it even shooting anything? Hey guys, welcome back. It's a beautiful day and today we're playing with something you should absolutely not try at home. I hate to be the one to say that, but it's absolutely true. Now in our last video we tried using dry ice to see if we could make improvised carbonated drinks at home, and it worked. And I also suggested it may not be the best idea to put dry ice in a sealed container. I'm about to show you why. Now today's experiment was inspired by a comment from DotsoCat, who asked if we could try melting dry ice in a sealed Coke bottle. I think the question here is to see if we can get the dry ice to melt and hold it in liquid form, and if that really works, can we heat it up to a supercritical temperature? Now I'm sorry DotsoCat, the answer is absolutely not, but I am still going to go ahead and do the experiment anyway, just so you can see what happens if you try. Now I'm going to keep this experiment fairly simple for you. I'm going to use an empty 500 milliliter Coke bottle and a handful of dry ice. I've crushed this dry ice down into a powder so it has more surface area, the idea being it'll sublimate a little bit quicker. So all we really have to do is find a way to get our dry ice inside of our bottle, cap it off, and get very, very far away. All right guys, I just smashed up the dry ice. I used funnels, I used my hands, I used every method possible to try and get the dry ice into these bottles. And here we are. I filled one bottle up nearly to the top with dry ice snow, and I filled another bottle up only about a third of the way full, so we can cap them off and just observe if there's any difference as the dry ice starts to warm up and sublimate. Here we are guys, moment of truth. I've got rolls of duct tape here on the bottoms because as these bottles fill up, they probably are going to pressurize and swell, and I want them to be held relatively in place. So let's go ahead and put the caps on the top now, seal up nice and tight, and then get very, very far away. Which bottle is going to explode first? The one with more dry ice or the one with less? Put your predictions down in the comments below. It's hard to tell if the one on the left is actually swelling up or if it's just pulling moisture out of the atmosphere and growing in size from the frost. This could be a really long process. I can see that bottle expanding. It's almost there. I can't believe that's held on so long. But that's gonna go any second. Well, I'm getting excited. I'm tired of being so nervous. Explode already. Whoa, oh my goodness, oh my goodness, oh my goodness. That was amazing. Boom. That was very, very loud. Dude, that was a big explosion. That was massive. Who knows how long that's gonna take. The hardest thing about this is you never know exactly when it's gonna go off. Okay, I'm sticking my neck out here for you guys. I'm gonna see if we can get you a little bit closer there. You can actually see the liquid CO2 in the bottle and small chunks of dry ice floating on the top. There's a small leak in that bottle, which is why it hasn't exploded yet. But if you look at the neck there, you should be able to see all the cracks. Like that thing is very unstable and it's ready to go. Makes me really nervous being here. Oh, you can see the carbon dioxide still bubbling in there. It's turning into a gas. I do not want that to go off right now. That would hurt tremendously. There we go. Yeah. Quick update guys, the bottle has grown about as big as it can get without exploding, but there's a slight leak in it, which means the gas is hissing out faster than the bottle can explode. This is a very dangerous situation because it could theoretically sit here indefinitely until something pokes it or pushes it and causes the reaction. So to help catalyze the reaction and bring it to a little safer condition, I went and got a BB gun. Here we go in 3, 2. A little high, okay, resetting. Here we go in 3, 2. Is it even shooting anything? Trigger, trigger. That was not me. I did not do that. Whoa, woo, doggy. So that was crazy guys. I went to shoot it with the BB gun and it actually blew up by itself like seconds before I pulled the trigger. So even though it had a hiss, it was actually pressurized enough to self-explode, and now there are pieces everywhere. And that was loud, like that's earplug worthy. You can hear bubbling and cracking over here. I mean, look at this. Look at this piece of plastic, guys. It is almost like melted and warped somehow. You can hear it cracking. It's almost like it's got some kind of permanent burn from the CO2. I don't know. It's turned to like a styrofoam texture and it's got different layers. That's really interesting. I haven't seen this before. The rest of this plastic is clear, but this almost looks like a foam, a styrofoam or something of that nature that I can peel off. Look at that. What the heck? What on earth? How do we turn plastic bottles into styrofoam? I don't get it, but that's what happened. That's crazy. Very, very exciting. Very, very exciting, and hopefully a lesson learned about why you don't put dry ice in soda bottles. Let's talk about that. So we started this experiment today to see what would happen if we put dry ice inside of a soda bottle and screwed the lid on tight. Would the carbon dioxide melt down into liquid CO2? And if so, could we heat it on an oven to make it go supercritical? The answer is kind of. Yes, the dry ice did melt down into liquid CO2, but the problem is these bottles are only pressure rated for around 150 to 200 psi. Whereas once dry ice melts, the pressures can increase to well over 1000 psi. So obviously it's just a matter of time until your container is going to explode. Now in this case, the results were surprising. We filled up one bottle almost full with dry ice and the other one about a third of the way full. What we found was the bottle filled a third of the way with dry ice exploded first. The reason I think that happened is because as long as you have dry ice in a solid state, it's going to keep the liquid cool. But once all the liquid has completely melted, it can all rise in temperature and increase the pressure dramatically. So the bottle we filled up nearly to the top with dry ice took over 45 minutes longer to explode. And it's kind of unpredictable when they're going to go off because it all depends on temperature, humidity, and whether or not the bottle springs a leak. So to answer your question, can you put dry ice in a bottle and have it turn to liquid CO2? The answer is yes. But should you? Absolutely not. By putting dry ice in a sealed container, you are essentially making a bomb. A dry ice bomb, as it were. And in most states and counties these days, dry ice bombs are illegal for obvious reasons. But what really surprised me about this experiment is how long it took for the reaction to take place. How long it took for the bottles to actually explode. The first bottle took almost an hour and a half. The second bottle, almost 2.5 hours. Based on all my experiences working with dry ice, my honest suggestion to you is please don't try this at home. You really never know who you could end up getting hurt. But I'm really glad that you could join me for this experiment today so you could observe the power of the reaction for yourself. And of course, a big thanks to our friend DotsoCat for suggesting this experiment. You can go ahead and check your YouTube inbox. I'm sending you 25 bucks. Thanks for joining me for this experiment, guys, and I'll be looking for you in the next one. Talk to you then. Oh, just broke my funnel. That's what happens when it cools down and you smash it too hard. Sorry, honey.